thing. It's not a detector, it's just graphing motion. Okay, why was graph matching velocity time graphs more difficult than distance time graphs?
Because you have to like think in a different way than what you're used to about target accelerated, constant speed, or like.
Exactly. Both of those things are exactly right. It's hard to think about your acceleration. It's hard to have a constant acceleration. It's easy to have a constant speed because we're good at having constant speed. All right, constant speed. Having a constant acceleration is tricky. Trying to get a straight line in a velocity basically speeding up at a constant rate, that's tricky. And it is, we don't usually think about velocity, we usually think about distance. It's just tricky. All right, and down to our graph. Describe the motion when each of these line segments is seen in the positive zone of velocity time graph. So if you see one of these lines in the positive zone, if you see this line, okay, I'm running out of space. I apologize if you didn't make a big diagram. If you see this line in the positive zone of a velocity time graph, what is going on? So take 10 seconds and describe the motion that's going on here.
It's moving away. So the acceleration is increasing.
Constant speed would be just be flat.
Moving away.
This is why we're talking it out.
Yeah.
Iron sharpens iron.
Moving away, and it's
Some people better
faster the
bring
further
up
away
rails
it
up
gets,
speed.
so it's accelerating.
When you get to sometimes you'll be better than Chris.
Acceleration
You're
is
like,
positive,
"Dumb."
and velocity is positive,
You're already
causing us to get to that line.
She's already had chemistry AP, so you can tap that resource. Just be like, hey, could you do this? All right, so who can raise their hand and volunteer? Who has the courage to volunteer their answer? Okay, Adam, what do you got?
Moving away and accelerating.
Perfect. Yeah. You're moving away because you're in the away zone and you're speeding up, you're accelerating, you're speeding up and increasing your velocity. So you're moving away. So this is away and this is speeding up. Plus velocity. You're plussing your velocity. Excellent. Give me a thumbs up if that makes sense to you. Okay, yeah. So your line is in the positive zone, therefore all your motion is away, and you're speeding up because you're becoming more and more positive in your velocity. What if you saw it in the negative zone? What if you saw that same line, but in the negative zone? Take 10 seconds. Chat with your neighbor. Take some time. What's going on if you see that same line, but in a negative zone?
But it's moving.
You're still moving.
It's moving at a decrease going on towards
Are we seeing the acceleration is increasing?
yeah. So
Okay. Who can volunteer their neighbor's answer? Okay, Daryl, what do you got?
so it's moving towards at a decelerating rate.
Okay, we're going to try not to use decelerating. College Board hates that word, so we're not going to use it. So you're moving towards, and you are negative acceleration, positive acceleration? You're slowing down. You're slowing down. But if you were to talk about acceleration, would you say the acceleration here is positive or negative?
Negative. No, positive. Positive.
Positive. The slope of the velocity time curve is positive. So you're slowing down. If your velocity is negative, your acceleration must be positive. Here, you're speeding up. Your velocity is positive, your acceleration must be also positive. Chris?
Because they have to be different signs. And if you have to slow down.
Exactly. Yeah. Different signs, they must slow down. Okay? Okay, give me a thumbs up if you're with me. Okay, let's take a 30-second break. Let it sink in. You can copy diagrams all you want.
Okay. So it's moving towards the acceleration of the
Yeah, slowing down
If you look at the slope, the slope
Yeah, I was like, that's a rip.
I need a bigger
So
break.
it's stupid because in the wave zone,
Part of it,
slowing
does that
down.
make sense?
If we're in the wave zone and slowing down, it would be positive.
But
They're opposite speeds.
it's still done though. There's this thing.
Oh.
It's the
Positive zones, you know,
like a difference like
All right, there's our minute. I work on football seconds, like 10, take 10 football seconds. Okay, next one. What kind of motion would you have if your line in the velocity time curve looked like that? Take a few seconds with your neighbor, chat it out. You can probably figure it out just using process of elimination, but take 10 seconds.
It is going towards.
Oh, sorry, you meant that. It is.
No.
Negative
So it's going down.
velocity.
So the velocity is positive, but it's getting closer to being stopped.
It's a way.
Okay. Who wants to, maybe someone from, maybe the guys in the back center, that's not Scott or Spencer, someone who hasn't talked yet. What kind of answer do you have for this line with the negative slope in the positive zone of velocity? Okay.
It's going away and slowing down.
It's going away and slowing down. See, you can answer questions. You're good. Yeah. And that's true. It's in the away zone, but it's becoming less and less positive. So you're going away and you're slowing down, and it should make sense that the slope of the distance time, of the velocity time curve is negative. Velocity value is positive, acceleration is negative. You're slowing down. Same question. What if you see that same line? Let's pretend it's about the same slope. What if you see that same line in the velocity negative area?
You speed it up. There were like a lot of questions about this on the pretest.
Chris pointed out there's a lot of questions of like this on the pretest. That pretest is your semester exam. You'll be taking in the third week in December. So store it in there.
Big brain. Big brain.
Yeah. Push it into that giant brain of yours. That giant developing brain of yours.
Big brain time.
Big brain time.
16 down, 7 to go.
What'd you say?
Some of you 17 down, 6 to go. All right. If you haven't talked yet, let's see.
Negative.
Adam, Melissa, Thane. What kind of motion do you have here? Melissa. Toward, moving toward. Okay. Toward and speeding up.
So it's a negative acceleration with a negative velocity.
Yep, exactly right. You have a negative velocity and a negative acceleration, so you are speeding up. Cool?
Yeah.
All right. If you have any questions, put your hand up and wave it around. If you're with me, give me a thumbs up. Okay. Last one of this set. If you see some lines in the positive zone, if you see a horizontal line in the positive zone, take 10 seconds and tell your neighbor what you think is going on.
It's moving away at a constant speed.
Answer or question. Adam, you need a neighbor.
No acceleration. It's moving.
Lean forward and tell Thane what's going on.
It's still moving. Moving away, but it's not. But it's a constant speed.
Okay, so I heard it. Thane, what do you got?
Is it moving away at a constant speed?
That's exactly what's going on. So
What is
you're moving
at
away.
a constant speed?
Could we make that a thing? Like you get bonus points if you answer like, what is moving away at a constant speed?
No. But if by bonus points you mean more points on your tests and quizzes, then absolutely, because you'll get the points in tests and quizzes.
Right.
So you,
Oh, I was
we can do whose line points. You get a million whose line points.
I was
Okay,
wondering
I
if
get
you
a
did that
million.
code.
Whose line is it?
Absolutely, yeah. You get a million whose line points. Okay, guys, same question, horizontal line, but in the negative velocity zone. Take 10 seconds, tell your neighbor.
Moving towards constant speed.
Yeah. Do you feel that burning sensation between your ears?
No.
That's learning.
That's just
So yeah. So now you're moving towards, and you have a constant speed.
Where? Huh?
That burning sensation you feel, that is learning.
That is.
All right. Draw your motion. Okay, so we'll skip that. Exercises, here we go. Your options are A, B, C, D, E, F, G. Number 1. Oh, page 3. Page 3.
Hey.
Number 1. What motion is occurring when the line on a positive time graph is horizontal? Hey. What motion is occurring when the line on a position time graph is diagonal with a positive slope? B. What motion is occurring when the line on a position time graph is diagonal with a negative slope? C. Can the curve on a position time graph be vertical? No. In fact, I'll tell you right now, you cannot have a perfectly vertical position time or velocity time graph. Can't do it. Exactly. So for a vertical line, you would basically mean you are, if you had a line here and here, that means you are at that position and that position at the exact same time. Only Harry Potter can do that.
Instant transmission.
Can't do it. So you can't be in two places at the same time. And you also can't have two speeds. You can't be going 25 miles per hour and 10 miles per hour at the exact same time. Okay, there has to be some sort of movement in there. Now I say that because when you are taking tests, sometimes it's easier for me to draw a straight line, and I don't want you to come up. I know some of you are like, but Mr. Bias, it's a straight line. You said no. It's just easier for me to draw a straight line when I'm drawing the graphs on your quizzes than to draw like a slightly curved line. Just easier that way. So just forgive me. I'm just gonna fudge it there a little bit.
Put in that extra.
I know. You're letting us down, Byers. Okay, Chris.
So when you're changing speed, does that mean that the velocity would be like this, and then it would go down vertically and then horizontally continue?
If you had motion that you saw that looked like that, what it would really look like is that. And if you had velocity that looked like this, what it really looked like is, well, okay, if you have velocity that looked like that, what it really looked like is this. Okay, does that make sense? So, jagged corners and stuff, they just don't really exist, but they allow us to simplify graphs, if you will. Next, what motion is occurring when the line on a velocity time graph is horizontal and positive? B, yeah. What motion is occurring when the line on a velocity time graph is horizontal and negative? C, yep. When the line, there's number 7. I think it's number 7, right? The next
Yeah,
one.
it is 7.
When the line on a velocity time graph is in the negative, diagonal with a positive slope. Negative, diagonal with a positive slope. G. Yep, it's G. Excellent, excellent, excellent. When the line on the velocity time graph is in the positive, diagonal with a positive slope.
D.
D. Yep, D.
I think you get that one
When the line on a velocity time graph is in the negative, diagonal with a negative slope.
F.
F. And lastly, when the line on a velocity time graph is in the positive, diagonal with a negative slope. E. Well done, E.
right.
Okay, are we good? Okay, we've got 5 minutes, no, a little more, 10 minutes left. Number 11, what motion occurs when crossing the x-axis on a velocity time graph?
Change in direction.
Change in direction. So if you had a line that looked like this, you are slowing down, coming to a stop, and speeding up. If you had a line that looked like this, you're slowing down, coming to a stop, and speeding up. Can you think of a situation where you might have motion where it's slowing down, coming to a stop, and then speeding up again?
Stop. In a change of direction, you have to stop.
Gravity.
Maybe it's like that.
Oh, that's funny. You're doing it right now.
Got him.
Yeah.
Got him good.
That's a good one. That was a good
Fast, slow, stop, slow, fast. Fast, slow, stop, slow, fast. Fast, slow, stop, slow. You see it stop up there for just a second?
Yeah, in the air.
Like just that instant, you're like,
High pull.
fast, slow, stop, slow, fast. So, yeah, so which of these lines, left or right, if my hand, listen carefully, if my hand is the point of origin, which of these lines best graphs the motion of the ball? Left or right? Chat with your neighbor.
The right. Cause it.
The motion.
No, wait, no, the left. Cause it goes
The
away.
left graph or the right graph?
It's the left.
If my hand is the origin
Stops and then
or the
comes
point
back.
of reference, Which one?
Left graph.
Left graph.
Okay, if you think it's the left graph, raise your left hand. If you think it's the right graph, raise your right hand. So it looks like left, 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 left. So my ball is going away, slowing down, stopping, and then coming back and speeding up. Away, slowing down, stopping, coming back and speeding up. Left graph. Oh, again, there's that burning sensation when your ears. Huh?
I got
Okay, give me a thumbs up if you're with me so far. Okay. Good? All right, cool. Number 12, how is displacement different than distance? Adam.
Distance is quantity which is only magnitude, while displacement is vector which means that both magnitude and the
Direction.
that direction.
Yeah, exactly right. Yeah, so distance just has a magnitude, 45 miles. Displacement has a magnitude and direction, 45 miles east. So displacement has a magnitude and direction. How is velocity different than speed? Same thing, right? Speed is just 45 miles per hour. Velocity is 45 miles per hour west. If velocity is positive, displacement must be positive or negative, increasing or decreasing? Increasing. If velocity is negative, displacement must be positive, negative, increasing, or decreasing? Decreasing. And now we have the graphs, which we don't have time for. Let's see if am I going to use the whiteboard anymore today? Nope. Nope. And I don't know. Okay, so we're gonna go ahead and try it. Okay, I need 1, 2, in 5 minutes, I need 4 volunteers. Military volunteers. So I have, I only have 3. Okay, I need 3 volunteers to put their work on the board.
Which 3 do you think? There's 4.
I know. So with the football player, Charles, you get to graph the football player. With the, that's the first one. With the tennis ball, Seth, you get to graph the tennis ball. And with the, oh sorry, yeah, you can do the Seth, you can do the tennis ball. And Chloe, can you do the squirrel, please? So hopefully those are still going to be up there tomorrow. We'll be able to talk about them. So go ahead and take some time and scribble your work up there and see if your work matches their work. Yes.
Right here. Where you